Now we're going to do the verification steps. First is check that solution agrees with the mathematical model. Are the boundary condition on deformation and traction satisfied? Yes, we have checked that at the fixed supports we are getting the deformation of 0 mm. Second, equilibrium satisfaction. So applied force and reactions are matching. Checking with the numerical error that you can do by yourself by changing the mesh sizes. You will observe that there is not much difference in the results. And the last part is checking with the comparison with hand calculation for reactions, internal forces and stresses and others. So let's do that. So this is a free body diagram which I have made. So this is a truss cross section area 5 meter by 5 meter. This is the forces 10 kilonewton at B point and 10 kilonewton downward and horizontal 10 kilonewton at C point. At D point we are having a roller support and A point is fixed support. So we'll have two reactions AY/AX at A point, and at D point we will only have dy reactions because it's free to move in a x direction. If we'll talk about external reactions, summation of fx equals to 0. So Ax plus 10 kilonewton equals to 0. So we'll get Ax equals to minus 10 kilonewton. Summation of moment about A equals to 0, right? So we'll write down minus 10 into phi plus 10 into phi, right? And dy into phi, right? So we're taking anti-clockwise as a positive and this both the clockwise as a negative. So that will give us the dy equals to 20 kilonewton. Last part is summation of f of y equals to 0. So Ay plus dy equals to minus 20 kilonewtons, which will give us the dy equals to 20 kilonewton, right? So this was about the balancing the forces. Now let's check this with the ANSYS results. So this is our ANSYS part. At force reaction at x axis at point A, let me look into the normal direction. At A location we are getting in x direction minus 10,000 Newton. That's what we got in this also, right? Minus 10 kilonewton. Let me keep this side by side so I can compare. At A point, y direction reaction is 0, which is almost equals to 0. We are getting 10 to the power minus 12, correct? At this point, D point, we are getting y direction equals to 20 kilonewton, positive 20 kilonewton. That is matching with our hand calculations results. Now let's see the internal forces. So this is after getting the reaction, we have kept the reaction here and applied force here, and this is the diagram of member forces, each member forces that has been resolved. So let's start with the D point. At D point, here we are having positive CD, here it's minus 20 kilonewton and AD equals to, so here AD equals to 0 because we don't have x direction forces anything, right? And dy equals to 20 kilonewton, that we already done. Next let's take point A, point B. At point B we have this minus AB minus 10 kilonewton, that gives AB equals to minus 10 kilonewtons. BC we don't have any forces here. So let's check this forces in AB, that's our first beam, this bar. It should have the internal force of 10 kilonewtons, right? So I have opened the ANSYS mechanical. AB we are having a minus 10 kilonewton. Let me go to display and check for the probe. if I'm putting into AB beam, we are getting the internal force of minus 10,000 kilonewton. Similarly, for joint C, we have resolved and we got AC as 14.14 kilonewton. So let's check out in AC, it's 14.142 kilonewton. Now let's find out in CD, right? So in CD at this location, we are getting minus 20,000, same as hand calculation results. So it shows that the ANSYS calculation matches with the hand calculation. So that was the last part of verification. We can also check the stresses. Just divide by the area of 10,000 square, and we have verified that it's matching with the ANSYS results, right? So we'll see the stresses also. If we'll probe here, so it's minus 20,000 divided by 10,000 area, so we are getting the stress of 2 megapascal, right? So that was about this stress sessions. Hope you understood it, and do the practice of the project which we have assigned you. Do well, and if you have any doubt, just ping us back.